There are 5 big sort of classifications for reactions. Let's go through them one by one. The first one is called combination, or sometimes it's called synthesis. So you might see either of those names. Combination is very much what it sounds like. You would take one thing, and it's separated at first from another thing, and these are representing different compounds. And then kaboom, a reaction happens, and they are both together. So that is combination, the first sort of big category of reaction. The second type of reaction is called decomposition. And a decomposition is really the reverse of a combination. So let's say you had a combination. What you ended up with in a combination reaction is what you will start with in a decomposition. So we'll have this product. That will be the first thing. Then you have the kaboom. Those two things that were together end up apart. So the elements have decomposed. They were together, and now they're apart. So decomposition, the opposite of combination. It's the second big category. A third big category is called single replacement. Sometimes you'll also see it called single displacement, tomato, tomato. Single replacement. Okay, so that's if you have one element all by itself, and then, in addition to that, you have two other elements that are together. And then, kaboom, reaction happens, and the element that was by itself, takes the place of one of the elements that was together. So notice how B here was in a cozy situation with C. It was connected to it, but after the reaction, it's all by itself. It was replaced. One thing, single, the B, was replaced by A. So that's a single replacement. Okay, what if you had two things together? Oh, the fourth thing, let's see. The fourth thing is called double displacement or double replacement. Tomato, tomato. So double replacement. Could also see double displacement. And you get that when you have two things that are together, and in addition to those, you have another two things that are together, and you get kaboom, reaction happens, and they all scramble. So A was with B, but now it'll be with D. So B got displaced or replaced. That's one replacement. And then C was with D, but now it will be with B. So C used to be with D, now it's with B. That's a second replacement. So this is two replacements, therefore a double replacement reaction. It would be as if one pair of turtles went on a date with another pair of turtles, and they realized that the real turtles they were all in love with were the other turtles, and they switched. So that's double displacement. Oops. Okay, so last but not least, so those are all very general. Last but not least is a specific one called combustion. So combustion is very specific. You need a hydrocarbon. Now I'm going to put, a hydrocarbon is something that's made just of hydrogen and carbon. It doesn't matter how many specific carbons and hydrogens you have, so I put X and Y at the bottom there. But specifically, hydrocarbon plus H2O, water. And this gives you carbon dioxide and, you take this and you need oxygen, forgive me. And you always get carbon dioxide and water. So this is combustion. A hydrocarbon plus oxygen gives you carbon dioxide and water. Very specific reaction. This is a reaction happening in all of our cells all the time. It's the reason why we breathe out carbon dioxide and we pee out urine. And it also happens anytime you burn wood in a fire or you burn a candle. This is the reaction that's happening. So it's a very specific reaction, whereas the others are general. Okay, so that's an explanation of these. Now we can take those and use them to complete exercise 13 in chapter 12. So notice how here we have two things that are together, aluminum and oxygen. They start out together, but they end up apart. They end up apart, so you have them separated by that plus sign in the end. When you start out together but end up apart, that was decomposition. So this would be a decomposition reaction. Oops. Okay, how about with B? Well, with B, we have bromine, that's one thing. It's separated from a second thing. So notice how the plus signs are really useful here. Oh, and actually, that second thing is a compound. So we've got barium and iodine together. And then in the product, barium is not with iodine anymore, it is with bromine. So iodine got replaced. Iodine is all by itself. So one thing, namely iodine, got replaced, so this is a single replacement. You could also say single displacement. Okay, C. We've got carbon and hydrogen, followed by oxygen, CO2, and H2O. That's a very specific one, combustion. Combustion. So that would be combustion. And actually, this is the reaction for for welding guns. When you want to weld metals together, those flames that you see, the reaction happening in those flames is this reaction here. For D, all right, let's check it out. We have barium, and it's together with chlorine. Beautiful. And then we have potassium, and it is together with carbonate. This is a polyatomic ion. Interesting, interesting. Well, we have barium again in the products, but it's not with chlorine, it's with carbonate. What? That's one thing that got replaced. And then we have potassium also in the products, but it's not with carbonate, it's with chlorine. So that's a second thing that got replaced. Two things that got replaced, why, that's double replacement. So this would be double replacement. So, E is another one to look at. So E, we have lead, it's all by itself, okay? Then we have oxygen, also all by itself. What? And then they come together to form one thing? Why, that, two things that start out separate but end up coming together, that's combination. So this would very clearly be combination. So in each of these, you're comparing the specific reaction they give you with these sort of general classifications. If two things start out separate, end up together, it's combination. If they start together but end up separate, decomposition. If one thing gets replaced in a compound, it's single replacement. If two things get replaced in a compound, in two compounds, double replacement. And if it's a hydrocarbon plus oxygen gives you carbon dioxide and water, it's combustion. And that's how you would classify these reactions.